Do you understand? As the van der Waals forces are increasing, the attractive forces between the molecules are increasing. It means that molecules are going to be coming closer together, right? For chlorine, the molecules might be this close. For bromine, they might be more closer. All right. For iodine is a solid. Iodine is solid. So for it to be solid, iodine molecules are going to be like this, tightly packed. Close, loosely packed. And for chlorine, they might be widely spread. Maybe let's make them in further apart. Like gas, widely spread. So these are the arrangement of the atoms molecules that we have studied according to the van der Waals forces, according to the forces of attraction between their molecules. Okay, is this making sense, Eileen?
जी सर.
समझ में आ रहा है ये?
Yes.
Very good, very good. So as you're going down the group, we know that the size is increasing. We know as you're going down the group, the size is also increasing. So as you're going down the group, you see the atomic size increases, the number of proton and electron increases, the mass increases. All of these things, they contribute in the increment of the van der Waals forces. So when the van der Waals forces are going to be increasing, as you go down the group, the atomic mass increases. This increase causes a rise in the attractive forces between the molecules, the van der Waals forces. That is why the melting and boiling point increases as you go down the group. It increases as you're going down the group, right? Is this making sense?
Yes.
Similarly, as van der Waals forces are increasing, the molecules are coming closer to each other, right? So for chlorine, the molecules might be like this. For bromine, the molecules are going to be somewhere like this. For iodine and astatine, the molecules are like this. So as they are coming closer to each other, they will allow less light to pass through. Kalishba, do you get it? If in
जी
a jar
सर.
you have something which is like this, would this allow more light, or would this allow more light to pass through? Which would allow more light to pass through? This would allow more light to pass through. This would allow less light. So this is going to be darker because this is not allowing any light to pass through. And this is going to be light in color because it is allowing light to pass through, right? It's going to be more of a transparent, right? More transparent, more opaque, not allowing any light to pass through. Remember, you understand? So that is the reason. This is the reason. Another point that we have to keep in mind, as you go down the group, the van der Waals forces increases, the particles come closer to each other. This allows less light to pass through the elements, the element and down the group halogens become darker and darker. So fluorine is almost transparent, right? Almost the lightest in color, almost colorless, you can say. Chlorine is greenish yellow. If you look at bromine, it is reddish brown. If you look at iodine, it's purplish black. If you look at acetylene, it's black. You see? So it means it is solid. This is also solid. This is liquid bromine. This is gas. This is gas. This is making sense?
Yes.
You're not just discussing what is going on as you're going down the group, you're also discussing what is we're not only discussing what is going down, what is happening down the group, we are also discussing why it is happening. That makes sense, right?
Yes.
Right. Just to summarize this, the trends, the trend down the group 7 trend down the group. And this is for all the non-metals. The reactivity. We will discuss that. Uh, I'll just write it over here as well. So the first one, atomic mass. This is just the summary. Mass increases. Number 2, number of protons and electrons, they increase. Number 3, size increases. Number 4, when der Waal forces or intermolecular forces, they increase, right? Increase. 5, melting point and boiling point increases. 6, the color gets darker. All right. What else? Number 7, molecules come closer to each other. And this is related to van der Waals force, by the way. Number 8, and the last one, which is an important one, we'll discuss that inshallah in the next class. And that is their reactivity decreases. This is the one thing that is decreasing. Their reactivity is decreasing. And this is the case for all non-metals. For all non-metals, their reactivity and their non-metallic nature decreases down the group. What is their non-metallic nature? Ability to accept electron, right? To accept electron. You can also write down the group their, their oxidizing power also decreases. Okay, also decreases. Why? If they are not able to gain electron very quickly, it means they will also not be able to make others lose electron very quickly, right? So they become, so in other words, down the group, all non-metals lose oxidizing power, or in other words, you can say they become weaker oxidizing agent, right? I just want you to write this down. The next class, inshallah, we'll discuss the chemical properties.